At the bottom of the Mediterranean Sea, more than 15 meters down, there is a wall that has been submerged for over 2,000 years. It is not a reef. It is not a geological formation. It is concrete. Concrete that someone made with their hands before any modern nation on Earth existed. And here is what no one can explain. That wall is not crumbling. It is getting stronger. Meanwhile, on the surface, in any American city, any Mexican city, any European city, you can find parking structures that are not 30 years old and already fractured, steel rebar pushing through the surface like broken bone. According to the American Society of Civil Engineers 2025 Infrastructure Report, more than 41,000 bridges in the United States alone are classified as structurally deficient. The cost to repair them exceeds $69 billion. Just bridges. Just one country. The Romans built entire harbors under the sea with a material that heals itself. And we cannot keep a highway overpass standing for half a century. To understand how that is possible, you have to travel to a small coastal town in southern Italy called Pozzuoli. Set inside the Campi Flegrei, one of the most volcanically active regions in Europe. Imagine a Roman worker, a man with no name that history ever recorded, standing on a beach of gray volcanic sand. He had no university degree, no laboratory, no instruments. He had something we have largely forgotten, the ability to watch nature and learn from it. The Romans noticed that the volcanic ash of this region, that gray, porous sand, behaved differently from anything else they knew. When you mixed it with quicklime and seawater, the mixture heated, hardened, and instead of weakening over time, it grew stronger. They called that powder pulvis pudiolanus. We call it Pozzolana. But Pozzolana alone does not explain the mystery. For nearly 2,000 years, the world believed we understood the recipe, thanks to Vitruvius, the Roman architect, who, in the 1st century BCE, wrote De Architectura, the earliest surviving treatise on architectural theory. Vitruvius described a process where water was added to lime first, creating a slaked paste before mixing with the other ingredients. That was the accepted version for centuries, until someone decided to actually verify it in 2023. A team at MIT, led by Professor Admir Masic, published a paper that changed everything. The Romans did not slake the lime first. They mixed raw chunks of quicklime directly with volcanic ash, dry, and only then added water. Pause on what that means physically. The moment water contacted unslaked lime, the reaction was immediate and violent. The heat was real. The hands mixing that material felt it. Roman workers were handling a substance that literally burned as it activated, reaching temperatures above 200 degrees Celsius inside the mixture. And that heat was not an accident they tolerated, it was the mechanism. This process, which Masic's team named hot mixing, trapped small white clusters of reactive lime inside the hardened concrete. Scientists call them lime clasts. Centuries later, as microscopic cracks began to form, those clasts came into contact with filtered water, released calcium that precipitated as carbonate, and sealed the crack from within. In MIT laboratory experiments, this process took just 14 days. 14 days for a material to repair itself. No human intervention, no cost. But that was only the first mechanism. In 2017, geologist Marie Jackson at the University of Utah, working with Lawrence Berkeley National Laboratory, used X-ray diffraction and electron microscopy to examine samples of Roman concrete pulled from the seafloor. Inside the pores, seawater had been reacting with the volcanic compounds for centuries, forming crystals of a rare mineral called a luminous Tobermorite. These crystals grew as rigid plates, functioning as a microscopic internal skeleton. Millions of tiny mineral ribs reinforcing the material from within. Every wave that struck, every earthquake that shook the coastline, instead of destroying it, strengthening it. And in December 2025, a study published in Nature Communications revealed a third mechanism. Masic and his team were granted access to something no scientist had ever examined before: an active Roman construction site frozen in time by the eruption of Vesuvius in 79 CE in Pompeii, abandoned tools, stacked raw materials, walls mid-construction, a perfect time capsule. They not only confirmed hot mixing, finding intact chunks of quicklime pre-mixed with volcanic ash, they discovered that pumice particles were also chemically reacting with the pore fluid, generating entirely new mineral deposits over time. 3 mechanisms working in parallel across millennia: lime that seals cracks, seawater that grows reinforcing crystals, pumice that creates new mineral mass. As if the Romans had engineered a living organism, not a material. And here is where the story becomes genuinely uncomfortable. Because if this science is confirmed, if MIT, Berkeley, and the University of Utah have spent years publishing the results, the question that remains unanswered is this: why can't modern engineers who know exactly how this material works simply replicate it? What is actually stopping us? The man who unraveled that answer has a story nearly as remarkable as the concrete itself. Admir Masic was born in Bosnia. In 1992, as a teenager, the war destroyed his home. A tank crushed the building where his family lived. They fled to a refugee camp in Croatia. There, he could play ping pong or study chemistry. He chose chemistry. He began winning national Olympiads. When his parents emigrated to Germany, he stayed behind alone, living in a friend's basement, to finish secondary school. Because he had understood that knowledge was the one thing no one could take from him. He eventually went to Italy, completed a doctorate, worked with the Dead Sea Scrolls, and arrived at MIT. A war refugee who now teaches the world how to build better. He also founded the Refugee Action Hub, a program that has provided university-level education to thousands of refugees, with graduates now working at Microsoft and Meta. A boy who lost his house discovered how to build houses that cannot be destroyed. When Masic entered the Pompeii excavation site and saw the preserved material stacks, the tools, the half-built wall, his eyes filled with tears. He said he expected to see Roman workers walking between the piles, that it was so vivid, you felt like you were traveling through time. Then he added, smiling, that yes, he had cried looking at a pile of dirt, and the archaeologists had laughed at him. So, if we know it works, why aren't we using it? The first obstacle is technical. The Pozzolana of the Campi Flegrei has a specific mineral composition that does not exist naturally in most of the world. Common substitutes like fly ash do not replicate it exactly. It is like trying to make a dish with a specific regional ingredient using grocery store approximations. The chemists can name every component. The result is not the same. The second obstacle is time. Roman concrete reaches its maximum strength over decades. Modern construction requires a material to bear structural load within 28 days. Imagine a contractor explaining to a bank that the building securing their loan will reach full structural integrity sometime around 2075. The third obstacle is economic. The global Portland cement industry exceeds $400 billion annually. It functions the way it does because modern concrete has an expiration date. It cracks, it corrodes, it gets replaced. A concrete that lasts millennia does not generate recurring revenue. This is not conspiracy. It is the logic of a system built around continuous replacement. And right now, somewhere in your city, workers are pouring concrete that will begin degrading before their children finish school. But something is shifting. And what is shifting is not the science. The science was always there. What is shifting is that, for the first time, people are willing to bet real money, real projects, and real reputations on a question that has never been answered. Can a 21st century economic system adopt a material that operates on the scale of centuries? Or is time itself the obstacle no laboratory can solve? Some are already forcing the answer. Marie Jackson partnered with Silica X, a company manufacturing synthetic pozzolana from industrial waste. Together they placed slabs weighing over 1,100 kilograms in Long Island Sound, off New York, designed to grow stronger with each passing decade. Masic co-founded DMAT, which closed a $4.5 million funding round to develop modern concrete with Roman self-healing properties. And in March 2026, MIT and Cemex jointly launched Heirloom House, a project building modular concrete components designed to last 1,000 years. The project director, Brandon Clifford, said something worth holding on to. That architecture does not fail when it collapses. It fails when it becomes obsolete. And that if we treat time as a design material, we can imagine buildings that transform across generations instead of being replaced by them. Meanwhile, Portland cement remains responsible for 7 to 8% of all global CO2 emissions. If the cement industry were a country, it would be the third largest emitter on Earth, behind only China and the United States. The Romans had no electron microscopes, no artificial intelligence, no material science laboratories. They had patience, observation, and a respect for what the Earth gave them. They looked at a volcano and saw not destruction, but possibility. They took volcanic ash and seawater, two things anyone would discard, and made something that has outlasted every empire that came after them. Today we have all the science. We have the data, the nature publications, the slabs hardening on the floor of New York Harbor, and a war refugee at MIT who wept over Roman dust in Pompeii because he understood that dust was worth more than millions of tons of modern cement. The question is no longer technical. It is a question of values. Are we willing to build for those who come after us, or only for the timeline that suits us? Forgotten knowledge does not disappear. It waits for someone with the curiosity to find it, the intelligence to understand it, and the courage to use it. The Romans left their answer at the bottom of the sea. It is ours to decide whether we listen.